All right, so average atomic mass is the topic for discussion right now. So average atomic mass. So the first thing I guess I should make you realize is that, okay, so if you look at a periodic table, right? So let's say we looked at, I don't know, carbon, which is 6C, and you would see 12.011 whatever, right? So this number right here is the average atomic mass. And what it does is, for the different types of carbon, which we're going to refer to and call isotopes, the most abundant version is the one that's usually the closest to this number. So in this case, the most abundant version here is carbon 12. Now, is that always the case? No. It just depends on the percentages of your isotopes. It depends on how those percentages work together. But for the most part, this is a pretty decent representation. Okay? So again, average atomic mass takes into account how do we get to this 12.011. So what I'd like to do is I'd like to do a problem with you right now. It's on page 12 in your packets, and it's number 2. And hopefully this gives you an idea. So what it reads is it reads this. It says silver exists as 51.84% 107 silver and 48.16% 109 silver. And then it furthermore goes on to tell you the actual mass of the two. So the 107 is actually 106.90509 atomic mass units, and the actual mass of 109 is actually 108.90476. So what we do to get the average atomic mass is the first thing we do is we take the percentage and we turn it into a decimal. So 51.84% as a decimal would be expressed as 0.5184. So that's the first thing we do. We take that 51.84, we make it into a decimal. Now, we then multiply that by the isotope. Now, normally I wouldn't give you the actual mass, but in this case I did. So it would be like 107 here. But in this case, I told you more specifically that version of 107 is actually 106.90509. Now, when you go to put this in your calculators, you want to put this in parentheses, because here's why. We've only dealt with the first 51.84%, but we have to deal with the other 48.16%. So here is the kicker of this. You add, and now the other as a decimal, 0.4816 times, and the 109 version of silver, which was told you in here, is actually 108.90476. So that's 108.90476. And all you got to do now, is as long as you put them in parentheses, is add them together. Now, because it's a percentage, and we have a rule about percentages, I would probably round this to the hundredths place. And so, as such, what you get is you get an answer of 107.87. And the label of atomic mass units. Put a box around it. There's your final answer. While I'm here, and you're here watching this video, let me do one more. Because in number 3, I give you percentages again, but I also just give you the isotopes. So it says, so it's about neon now. It says we have 90.5% neon 20. Well, 90.5% as a decimal is 0.905. And that version was neon version 20. Again, in parentheses, plus. It says the next thing is 0.3%. Well, that's a tricky then decimal, isn't it? Because 0.3% becomes 0.003 as a decimal. It gives 2 to the left, 1, 2, because it was originally 0.3, 1, 2. And that's a version 21. Again, putting in parentheses, and then plus. I have 3 isotopes here of neon, 20, 21, and 22. And the last one is 9.2%, which becomes 0.092. And again, that's a version 22. Just like on the last problem, when I'm ready, I then take my 3, I add them together, and I'm going to round to the hundredths place. And that's 20.19 atomic mass units. Now, one of the cool things about these types of problems is that the average atomic masses that you obtain, if you go look and find neon on the periodic table of elements, you have one in the back of your packets right now, what you would find is you will find that if you look at neon, you're going to find that neon, it says 20.18 here. Well, that's pretty darn close to 20.19. Or how about silver on the last one? 107.87 would be what would be rounded here, and we did get 107.87. So what I'm saying is you could check your answers and see if your answers are reasonable. And that is average atomic mass.